Well, hello there. I'm Jordan, and today I'm going to take you through my experiences as an incident responder. You're going to see firsthand how insecure coding practices can make for world-ending breaches. This talk is for security peoples. It's for developers, engineers, architects, users, and just like code-curious persons. And that's actually because at any point in my career, I've done all of those things. And so if I came to a conference and sat in your chairs, I would kind of want to hear something like this because it's fun, exciting, something different, and a bit technical. So, as always, who am I? Well, I'm Jordan. I'm a senior security consultant at Mandy and Google. I used to work for the Department of Homeland Security CISA doing incident response, as well as some other US government organizations. I got a master's in computer science from the Florida State University, and I am what I am calling a wannabe. For those that are familiar with extended Berkeley packet filtering, I just recently found out about it. I love it. I blogged about it. Come talk to me afterwards, because that is my newest computer fixation. So who cares? And more importantly, what are we even talking about, right? We're talking about secure code. Why should you care about secure code? Well, so your organizations don't get breached, right? There's a cost to this. It costs legal money. It costs compliance money. It costs incident response money. And possibly, probably, it'll cost your stock price too. Not good for anyone involved. Next thing, compliance, right? Sometimes compliance is just considered like checking off a box, but most of the time there's actually a reason for those boxes, and we'll get to that. The next part, code readability. Your software engineers, your security analysts, your program managers, your new hires, being able to quickly figure out what's going on in your code, super important, super valuable. And it's actually a byproduct of secure code. And last but not least, at Google, our site reliability engineers have a saying. It's you build it, you run it. In the context of secure code, this could mean kind of anything. But how I choose to interpret it for this talk is if you're a security engineer or a program manager or whatever, and you tell your SWEs, hey, I need you to develop in this manner using this way or this tools, have you tested it first? Have you sat with them and said, does this make sense? Will this impede your work? Will this drag out timelines? Definitely something that should be thought of. And at least for the context of this talk, you build it, you run it. Should be important to consider. So, table of contents goes, we're going to get on the same page about secure code. Then we're going to do some up-close encounters with incident response and how secure coding is the reason, or really insecure coding, is the reason why these incident responses occurred and these breaches occurred. And then last, we'll do a lessons learned wrap up. So what are we even talking about? Let's get on the same page, shall we? As I define secure code, I say it's an umbrella term for an ever-evolving list of secure practices to perform during the iterative software development process. It's a lot of words, but let's not dwell on it. Instead, let's kind of see what that looks like. And just as some audience participation, I know it's a little low, I apologize. Can anyone kind of identify what languages these are? I'll read it out loud. OS system? Python. What about stir copy?
C.
Yeah. And what about that bottom one?
That's Rust.
That is Rust. We love our crustaceans in the audience. These are considered insecure functions. You shouldn't necessarily use them, but maybe you have to. And there are reasons and exceptions for that, and we'll kind of get into those. But these are just insecure functions. That's one of like the many kinds of vulnerable code that you could have in your programs. Another kind of weird thing or bad thing that you can have are code smells. I actually had to go to the recesses of my computer science degree to kind of remember what this even was. Code smells, as defined by Wikipedia, is any characteristic of a program that possibly indicates a deeper problem. So ambiguous. So let's kind of give you an example. And I know these, that's a little small. So this is just a list of some code smells that I Googled. But let's talk about one of them. Let's talk about dead code. This is something you all have probably seen in your CTFing. It is kind of exactly what you would think dead code is. It's a function or some code that's in a file, but it's not actually called. And you'd actually be surprised at how often this happens, especially when your project starts to get over about 10,000 lines of code. Becomes a little much. So that's one example. Then in terms of kind of insecure coding practices, we come across bugs, right? It's definitely a little worse. I apologize, it's a little small. This is an example of a divide by zero bug. And incidentally, this is actually both a bug and a code smell. And so it's a bug because as the kind of definition theoretical side of it goes, this kind of issue leads to undefined behavior and the program crashes, right? But it's also a code smell because it could indicate a potential flaw in the logic or data handling. Makes sense. Oh, and so at the bottom here, we also have the solutions to these. So you have issues with your code with a code smell. What do? Refactor, rewrite it. That's kind of the best way to handle these things. Something else, threat modeling. I'll harp on that in a bit. Or SaaS. Any kind of automation tool, I think, is really valuable to not only free up people's time, but also make sure it gets done every time. And then as for bugs, some solutions, parameter checking, try except blocks, and then SaaS as well. This will become a common theme, and as we'll see that more in a bit. But the worst thing that you could have in a program is a vulnerability, right? CVEs, or what we call CWEs, common weakness enumeration, and we'll get to that. But this is this is a use after free error, right? For those that may not be too familiar with C, you have a pointer, you store something in it, and then you free that address, and then you print that address, or what's at that address after you have freed it. Not great. Attackers can definitely take advantage of that in a number of different manners. And so for the solutions, I'll read them out here. We talk about smart pointers. C has an embedded solution to this. There is unique pointers, shared pointers, and weak pointers. All of those are really easy ways of just like getting around use after free vulnerabilities, so they're not an issue. Or at Google, because of course we have to do it our own way, we have what's called a miracle pointer that's used all over Google Chrome's software stack. Yeah. So, now we're on the same page. Let's get into the juicy stuff, shall we? IR's up close. In my time in security, I found that stories and memes are the best ways to convey information in security. So as the HackSpaceCon theme goes, I figured the best way to do it is with the upcoming Marvel movie for Fantastic Four. And so all these stories are going to be a little themed. It'll be a good time. But I do want to mention all of these stories I'm about to tell you are real IR cases, incident response cases that I've worked on in my career, but they've just been kind of jumbled to the best of my ability to kind of anonymize any of the players or risk involved. So for those unfamiliar with the Fantastic Four, they are a superhero family that gains their powers from cosmic radiation while they're up in space in a space station. At least that's the canon version. And I'll try not to get too nerdy here. One of the great things about doing this talk is I literally got to spend hours just reading comics and watching like comic reviews online. This is a great excuse. So anyways, first up, the problem of everything. In Jonathan Hickman's Fantastic Four, issue number 571, we have the Council of Reeds. The Council of Reeds was this idea that from the multiverse, you have all these different Reeds who came to the same conclusion that he knows he's so smart that he can solve the problems of everything, what he called the problem of everything. And so one of those problems is famine and hunger and being able to kind of make that all go away. And so what they did was they took kind of these bountiful worlds that had just like grain and food, and they shipped them off to other parts of the galaxies to help people. And so this is where our IR begins. We begin with the International interdimensional food corporation. All of these stories are going to be related around secure code, just to get my point across. So first, they had great logging. They had 2-year retention of logs. They had XDR that worked great. And they had no network segmentation. But because they had, remote workers, interdimensional workers, they had to have a VPN. Now, what they also had to have was a way to keep count of their customers, right? They had to have a customer list. So what had happened was, as blue teamers and defenders go, it was mentioned in a previous talk, we love our spreadsheets. We can never get away from them. So much so that that was actually the customer database. And so what happened was the reads put together a quick little C program to essentially connect back to a server that was hosting that customer database, Excel spreadsheet. And it was quite simple, truly. It was just proprietary program, sends GET requests to a server through the VPN, and it will only retrieve that reads, that read will be able to retrieve the Excel file and, add, modify, whatever he needs to do. And the way that he did that was, or they would do that was, in the command line, they would just add what the name of the file was, which obviously would never change. It was just kind of a security by obscurity kind of feature. And the one other thing was the binary itself was allow listed. So the XDR, because the XDR kept alerting on it, and they were like, it doesn't matter. We don't do that. And so before I begin, to kind of tell you kind of the red side, the attack, I do want to take kind of a hot take for a second for 2025. But if you get popped by a 0-day, it is not your fault. Truly, it is not the product developers who may have been lazy. It is not the uninformed sysadmins. Sometimes attackers really are just that good, and we have to give them credit where credit is due. So, and that's why we have things like defense in depth to help out with that. But anyways, so what happens? We have the Mad Celestials, APT group, who got a 0-day on the Reed's VPN software. So they got through, they recon the network, they lateral moved to one of the Reed's hosts, and almost immediately, they were able to find the customers.exe binary. It kind of stuck out like a poorly disguised scroll. Surprising enough, the way they were able to find it, they actually checked the prefetch files. So the attacker themselves checked to see what files the current user normally runs. I thought that was a very novel kind of TTP that I haven't seen often. But anyways, so they found it immediately, and they were like, what is this? So they run strings, and they were able to kind of piece together, after doing some extra reverse engineering that we were able to see through the logging, that they had found a Stack Overflow vulnerability. So they kind of did their injection, and next thing you know, they were able to copy and exfiltrate the entire customer list. Sad, quite sad. But all that saying, during the IR, I do want to mention that the comprehensive logging really did help us piece this all together. And it really gave us a high confidence that we were able to go back to the customer and say, okay, we know for a fact that they used the 0-day only to grab your crown jewels and then leave. Nice and easy. So yeah, it was just a bit of a sad day for them. So as a Mandiant consultant, I will tell you how I consulted them. First, obviously, better authorization. We talk about kind of zero trust all the time. It could come in a lot of different forms, but nice and easy for them, it would just be, well, if you have to use that proprietary software, how about you maybe modify it to say that only that read can only have their customers instead of the whole customer list. Or even better, it is 2025. There are plenty of cloud IAM products that kind of augment this. Or, even better, don't have a custom binary grabbing an Excel file, right? We talked about the XDR, not allow listing that binary. Don't do that. As all the roles that I mentioned at the beginning that I used to do, or that I have done and are currently doing, allow listing is considered an exception. There should not be an exception in your environment. And if there is, it means there's a bigger problem at hand and it needs to be addressed. There needs to be a root cause analysis. And then while we're talking about allow listing, default deny. Just at any point, whether it's a firewall or anything, I'd much rather deny a user and then go through the process of like figuring out a ticket for them and finding that kind of one little issue to fix the larger issue, then just quickly allow listing. I know it takes a lot more time, but in the end, in the long run, it does make for a big difference. The next thing, just kind of run through these, STIGs and cloud secure scores. This is very much the idea of, hey, I have a massive network. I have no idea how many things could be wrong. I'm sure I have a couple things running in my head, but like I don't really know where to start. These products already do it for you. STIGs are freely available online. Cloud secure scores, you gotta pay a little, but I'm sure most of you already do that by accident. Another thing, could have used a safer language. Memory safe languages are a huge thing. I won't harp on that too much, but kind of to put it out there, Rust and Zig are two great options for that. Another thing, if you have to use a C binary or C++ binary, do yourself a favor, use safe compile arguments. Please make sure that you understand that GCC, at least to the best of my knowledge, doesn't turn on stack protections by default. So it's the, what is it? The F stack protector flag that will kind of it will put stack canaries in your running binaries or running processes. So at least it'll protect you from some things, right? It's not a fix, it's duct tape, but we make it work. Legal compliance. So legal compliance was another part of this IR, which essentially came down to just because you're a good organization doing good things, you know, feeding the multiverse, doesn't mean you are kind of exempt from fines and a massive PR hit. And that is what ended up happening to them. And they were quite surprised, which I thought was fun. And then the last thing, threat modeling. Boy, are we going to talk about threat modeling in a bit, but we got to keep this moving a little. I'm good on time, actually. Anyways, so our second story is about the Future Foundation. In Jonathan Hickman's Fantastic Four, issue number 579, Reed Richards forms the Future Foundation to help him with the problem of everythings, right? They were kids. They were kids from all over the world, smartest and brightest, and they were here to help Reed fix problems. In the comics, one of the problems they actually helped almost solve was Ben Grimm, the Thing. There's a running kind of story throughout all the different comics that like Ben actually doesn't like the way he looks because he can't turn on and off his powers like the rest of them can, and the kids sort of helped him with that. But anyways, our story actually starts with these things called timequake sensors. They detect travelers that came into the Baxter building, their kind of home fortress, also just a skyscraper. How they built it, it was not with any software design life cycle, nothing formalized, no risk management frameworks. It was very much just quick little, hey, I know Rust, which is a memory safe language, so good for them. But it was just a quick little sensor script. They did not use ePPF observability. Again, come talk to me afterwards. I love it. Yeah, they didn't have in the network running Falco or Tetragon or anything. But what they did have were a lot of troubleshooting problems. Usually when you write a script quickly, doesn't always work the first time. Or if it does, you set it up and you leave it on said IoT device, and then you realize, oh no, I have to change something. Well, if they're sensors and you don't have a centrally managed like patch service or system set up, you have to go to every one of those and change it. And it's very annoying. And the kids knew that. So they were like, oh, we're just gonna enable anonymous SSH login instead. Cool, fantastic. That is a solution. One other solution though, the Baxter building had a lot of brownouts, right? Some, you know, earth-shattering things happened around there. So the power gets cut every so often. Backup generators kick in, but it means all those services, they go down, right? And so what the kids did was they set up their sensors with a systemd service to spin it back up on failure, and that worked great. So those are the sensors. You know about them. Then we came in. We came in to do a purple team assessment, as commissioned by Miss Sue Storm. And so what happened? Well, our purple team had a red team component, or had a physical component of their red team. And they very quickly realized that's not a camera. That's a weird sensor. We need to be careful of that. So what's the first thing you do to an IoT device? You DOS it. It's kind of the easiest thing. But weirdly enough, the systemd service, because they added that restart on failure line, it came back up, no problem. So the sensors, before they were able to approach the building, they got detected, and they were like, well, gotta run back home and see what else I can do. So what's the next thing you do as an attacker? You nmap. You figure out what is exposed, or what is that application exposing, what services, right? And so real quick, they found that anonymous SSH. They came in, they killed the service, and they walked right through the front door. I know this is kind of like a very small, seemingly inconsequential kind of part of the IR that I'm talking about, or part of the purple team, but this was actually like detrimental, because this organization, you know, the Future Foundation and Fantastic Four, they were in a place where they really needed those sensors. They really needed to know who was coming into the buildings, if there was someone who was, you know, unauthorized. So this finding was actually the biggest one they cared about. You know, can't have any uninvited guests like Dr. Doom or the Shadow. Thank you. But anyways, from the consulting part, what do we advise? Anything open to the internet should have strict controls. That's kind of like a general, very obvious thing. Don't have anonymous logon. Use passwords, right? Or even better, just use authorization or SSH keys. What we also did suggest, because they were kind of in a pickle at the moment, was we said, okay, we don't like to do this, but do yourself a favor, add a WAF, add a web application firewall. You'd be able to control kind of the comings and goings of what's going to that sensor, but at least it's something, right? But we did emphasize, and I want to emphasize to all of you, that is a last-ditch effort. That should not be your first go-to. Another thing, we're going to get into a little bit of the weeds now. The risk management frameworks of secure coding. NIST put out this thing called the Secure Software Development Framework. And one of the things in it actually states PS 1.1, which is the produce well-secure software. It says use forms of risk modeling. Another way to say that, threat modeling. I am a massive proponent of threat modeling, anything and everything you do in life, but in security specifically. And threat modeling would have helped find all of these different things, or at least surface them to kind of tell your, to tell the higher ups and the project managers, like, hey, maybe they shouldn't be doing it this way. And the one other thing down here is a phrase that I haven't actually been able to attribute. I've been trying, and I find it in a lot of documentation. Google doesn't like to crash. That is a very, very true statement. You can obviously assume why that is at Google, but also just in general in all of your organizations, if you have kind of priority devices that always need that, you know, availability, one of the CIA triad ideas, something very important for you to keep in mind. So the last story, Dr. Doom's killer robots. In John Burns' The Fantastic Four, issue number 247, Dr. Doom had built killer robots in order to keep the peace in Latveria. That's kind of the country, city, state that he ruled over. It was both for the citizens to kind of keep the peace, and also it was for the other villains, as well as the Fantastic Four. If they ever came back to fight him on home turf, he would kind of have the advantage. But we'll get to that part in a second. So for the IR, these robots were built by government contractors. Now, Doom's government was run with an iron fist, pun intended. They mandated that all the industrial control systems were to be built on separate networks with separate laptops. They did use a best effort for the NIST Secure Software Design, or for the Secure Software Design Development Framework. And everything seemed to be going peachy. So much so that one day he had little Valeria, who is Reed Richards and Sue Storm's daughter, come and just be like, hey, Uncle Doom, how you doing? How's the project? Can I take a look? And he's like, yeah, sure, no problem. She ended up finding code smells. She ended up finding a message chain and a duplicate code smell, which I will leave to the as an exercise for the reader to figure out exactly what those are. But these kind of happen as projects get a little big and start to become not necessarily unmanageable, but just big enough where you need to start being a little more organized. So what did she do? She submitted a P0 bug. It seems harmless. So for the attack, remember how I mentioned that those robots were there to keep the peace and to keep Dr. Doom's enemies at bay? Well, Mussman, crazy guy. Mussman was so upset that his last run-in with Dr. Doom just failed so horribly that he decided to get together with him and his crypto mining army and wanted to get to Doom by destroying his robot program. So Mussman's kind of squirrely hackers decided to mark a single government contractor. After some time, they realized that he does his best work at the local coffee shop right on Main Street. So what did they do? They went into the coffee shop and they set up a little operation where when our nice little government contractor would come and connect to the Wi-Fi, he'd hit that Wi-Fi captive portal. As all of you have probably seen before, just like, hello, are you real? Click log on, great. Sometimes those have advertisements. Well, that day, it happened to have an advertisement that said, free drink, just click here. I'm gonna be honest, I would have clicked on it. And so the malware was downloaded silently to his laptop. And what actually happened was the malware was supposed to trigger when it got back onto the kind of office LAN. But Mussman has never been the most successful threat actor in the Marvel universe. And so, as the slide shows, Mussman got caught by the XDR. It was quite an easy thing. And the government immediately was like, oh my God, how could this happen? They immediately imaged the machine. We even got memory, which thank you. And they were like, hey, can you just real quick check for signs of exfil or anything else we missed? And we were like, yeah, sure, no problem. There was nothing, by the way. It was very clean. The XDR did its job, and we thank it for its service. Okay, so a lot happens in that story. And I actually want to start with that P0 that I kind of threw away mentioned. P0 fatigue is a real thing. We talk about alert fatigue for SOC analysts and security peoples. P0 is the same concept, whether it's in Jira or any kind of tool. The idea is you should not be sending tickets at the most extreme for all of them. That doesn't help anyone involved. It's not great. It creates what I kind of think of as notification overload, creates a backlog, and it kind of distracts the progress of your organization on one side. And then the other side, it degrades the momentum over time. So you kind of think of it as when you have all of this backlog, there are just a lot of things in the world, whether it's new CVEs that come out or new weird TikToks that the C-level has seen that, hey, are we susceptible to this attack? You need to check right now. And you say, we don't have any windows in our environment. And they say, check anyways. That causes us to not go back to those P0s that may actually be important. Or maybe it's just, I forgot my password. Can you reset it? even though you have a self-service password portal to do it yourself. So on this point, and then I'll continue on, remember anything not in moderation is a sin, except for cowbell. So anyways, second one, best practice, turn off machines when not in use. Anytime I think of fileless malware, as this was, there is an immediate knee-jerk reaction of just shutting off devices that don't need to be turned on. One, it saves money. Two, it's always been debatable whether it actually speeds up your system because it clears the cache. But most importantly, it will flush out that malware, right? So super important there. Next, keeping a close eye on contractors, right? Stricter rules, whether it's following a proper like NIST SSDF framework, or just maybe like a more generic rule of, hey, can you not take a laptop that looks like this? Sorry, for those of you, TSSCI Killer Robots Project. Can you not take that into a public coffee shop? I would really appreciate that. Thanks. Yeah. And actually, as a quick little thing for sysadmins or anyone in here that is curious, there is a Windows GPO actually that restricts the available SSIDs or the acceptable SSIDs that a computer can connect to. But that gets into making an exception, which means there's a bigger problem, which is don't let your government contractors take things out of secure spaces. Yes. Okay. Yeah.
Have you ever seen one have a policy of like turn computers off?
Sort of. The one that I can say is they essentially hid it as a update for users. So they're like, hey, don't forget, we're gonna restart all your machines beforehand. And so that kind of threat gives people some sort of warning that they'll like close all their screens or like save all their work, and they'll actually just turn off the laptops themselves and restart it. Yeah. Anyways, so lessons learned. So I appreciate you guys sticking with me for the stories, but actually this is, in my opinion, the most important part of this talk. These are the things that I want you to take away, because I've told you a lot of fun things about their attacker techniques and unique kind of ways that you could secure things and my consulting spiels. But so instead, let me just kind of summarize the takeaways that I think should be for all of you. And I do want to say some of these may seem like they're only for certain individuals in this room, certain job roles, but in reality, security is everyone's responsibility, and I think you should at the very least know about them. So first, I broke it down into 3 sections: plan, practice, and where to go from here. Plan, having a mindset. I know this is not technical at all, but I feel like this soft skill is the most important. Someone told me this phrase very soon after I arrived at Google, and it was, they want this to work too. Always go into a mindset of any kind of conversation, whether you know it's going to be argumentative, whether you know it's going to be aggressive, or maybe just a misunderstanding. Always think about this first, because at the end of the day, your mindset kind of like will show, and the other person will kind of reciprocate that, and it'll just make for a much happier conversation and almost always a better outcome. As the saying goes, you catch more flies with honey than vinegar, right? Next, risk management frameworks and code smells. So I mentioned one already, NIST, Secure Software Design Framework, but there are also others with not great names. The quote, Building Security and Maturity Model, BSIM, or OWASP, DevSecOps Maturity Model, DSIM. There are also others, but those are just kind of the 3 that I've seen used. I think it's super important to kind of have these kind of rules set up and predefined, so that going into specifically instances, you're able to kind of either lean back on those, or they're just kind of built in to your processes. We'll talk about that on the next slide. Next, I kind of mentioned it before, Google doesn't like to crash, and you shouldn't either. Availability, I think, is super important in our field. It just kind of gives you a sense of, hey, if things are always working, it means that there are competent people at the helm. And I don't mean that to say that that's the reality of the situation. I mean that as the perspective. And as my mom used to say, perspective is reality. The next thing, when we're talking about philosophies, we've heard this a lot. We have secure by design, which is CIS's pledge, and we have secure by default, which is Google's. Secure by design is very simply put security at the very forefront, at the very beginning of where you want to start your projects. And I don't just mean when you have your first Scrum meeting about it. I mean when you're sitting at a hotel bar and you have a great idea for this and you scribble it down on a napkin, you should immediately send that information to your security team. They are going to love you for it. And at the end of the day, it gives everyone a stake in making your systems better and more secure. So that's secure by design. Then you have secure by default. Google takes this a little further, and we kind of break it down into including the opt-in permission rather than defaulting overly permissive applications. I think that's a super great thing to have where, yeah, I'm not going to keep going on that one. Also, having MFA enabled, I think that's really great. I mean, identity is kind of the new frontier when it comes to kind of attackers getting around pretty much everything. You can have the best security, the best perimeter setup, but when it comes to, attackers looking for the easiest way to get in, you phish a user, sometimes the security team can't tell a difference if that user is who they say they are or it's some sort of masquerade. And then the last thing as part of Google's secure by default kind of philosophy is minimizing the need for users or administrators to take action to secure the system. It's kind of a mouthful, but essentially says, if you're the one building a system, architecting, building a program, building software, whatever it is, you should make it as easy as possible. Not necessarily turnkey, because I do believe that tuning is always a part of the process, but still making it as easy as possible and as not confusing as possible to kind of ship your product and just kind of make it work for everyone. So now okay. And then there's the last bullet point of the planning. Because we are at HackSpaceCon, we are going to pull from NASA's Jet Propulsion Laboratory. So they came out in 2006 with a paper called The Power of 10, Rules for Developing Safety Critical Code. It is kind of exactly as you think it would be. They're rules to just boost software reliability by banning risky programming practices. My personal favorite is Rule 7. Ooh, that is a not great color. Shout out to Claude for making that, though. Very great. Rule 7, it contains two things. It says, 1, check function return values, and it also says checking the validity of parameters passed. Parameter checking obviously is to kind of mitigate injections. But in terms of parameter checking, in terms of checking the return value of functions, that actually makes your code more readable. And I don't just mean, hey, did something return? I mean, hey, was I expecting an int? Or do I even care about the return value, right? In Rust and a handful of other languages, you can just set the underscore on the left side of the equal sign, and that's saying, I don't really care about what's returned. That in itself can tell code reviewers and security analysts and whoever else that we don't necessarily care about this return value just by reading the code, right? We don't have to worry about them commenting or some system kind of generating documentation that may say it's one thing, but in fact is something else. So just relying on what the code actually does and not what the comments may say, I think is super beneficial. Yeah, and the last little part of this is, or actually on this, on YouTube, if you check out the Primogen, he has a really great commentary on the Power of 10 rules. So second point in this, second point in this is the practical. So we have the philosophy, we're talking about rules to create, we're talking about just like getting on the same page in your organization. Next is actually implementing those rules. Usually we do it in linters or like pre-submit checks. So it's really just, hey, your code, we want it to look a certain way. You're going to put those rules into your linter. And whether or not you create those rules or you kind of use the default rule set from whatever language is standard that's being used, that's a really great, easy kind of inject to help your developers write more secure code. Another thing is using those SAST and DAST tools. Those are the static and dynamic application security testing tools that are just the augmented version of linters and pre-submit. So you have kind of the basics of just a linter looking over your code saying, does it look good? Does it conform to whatever policy standards? And then you have SAS and DAST, which will return you those CWEs, those common weakness enumeration. For those unfamiliar, that's kind of the equivalent of the MITRE ATT&CK framework, giving you like TTPs when a attack process is run or attack cycle is run, and it'll like mark all the different things. This will also mark all the different things in the CWE kind of framework. Oh, and just one other shout out, because again, Google, we like to do things our own way. We have our own OSV scanner if you would like to check that out. The one other bullet there, AI. It's 2025, you can't get rid of it. Most of your project managers want you to integrate it in everything. Here's actually an easy way to do that, just to kind of please everyone. But to be honest, it does help from time to time as well. I have seen it work with the idea of just running your code through, and I want to make this clear, an internal kind of your own AI, right? You talk about like data sovereignty and like who owns it, where's your code. I wouldn't necessarily just use that API key that Claude gave you or whatever and send your code out there because that's not great. But instead, use that internal AI, scan your program, and anytime there's an alert, mark it as a warning, right? In those pre-submit checks, don't necessarily stop a commit from going through code review, but you should let people know because I think it's important. Okay, threat modeling. So I kind of talked about this before. Oh, well, okay. I kind of mentioned this before, that I think threat modeling is the most important thing that you can do for your organization. I think that there are a number of different formal processes, right? You have Stride. You also have like kind of other silly names like Pasta and Trike. That's just a funny thing to share. I don't necessarily think there's any value in that. It's kind of like how in programming you have a nibble, which is a half byte. Again, it's just funny. But anyways, yeah, threat modeling using a formal model, I think is a great way to go. But you could also do something a little more plain and simple. And apologize for people over here, so I'll read it. Adam Shostak, he's a security researcher. He came up with the 4-question framework for threat modeling. Question number 1, what are we working on? Question number 2, what can go wrong? Number 3, what are we going to do about it? And 4, did we do a good job? And I love that last one because it kind of feels like your mom guilting you when you're like doing your homework. It's just like, did you really do a good job on this homework to get an A, or was it just enough to beat the curve, right? And I think that's super important that we should do in anything we do these days. It's just like, hey, last thing before we move on to the next project, did we do a good job? But yeah, so that's the kind of tooling and putting it in practice. And so my last final slide, and I really want to emphasize, this is, in my opinion, the most important slide. Where to go from here? Don't start over. I've given you a lot of great tips. I'm sure at the conference you've kind of heard a lot of great things that you may want to come back to. And I would hope you, online, revisit this talk and kind of remember this point. Don't start over. Do not, when you get back to your home office on Monday, say, okay, I'm going to add DASTs and I'm going to add all these different awesome programs, because you will not win friends that way. Most likely, you probably won't even get that promotion, I think. I don't know. But what this means is, think about first how you can easily kind of work with people, work with your developers, your security engineers, but also just the program managers, really, and say, what makes sense, right? What can I actually do to inform the software engineers that maybe this isn't the best way to go about things? And in some cases, that could be, creating, as it says here, like creating the least amount of friction. And what I mean by that is, in kind of UX design, there's a kind of story that's been passed around, which is, if my user has to create an account for my calculator app, that user will not download that app. They will go to anything else and use it and move on. And I think it's the same for security too. If you tell your developers, hey, before you submit code, can you drop it in this like bucket real quick, or this like assembly line of programs that'll do all these different things, and then you yourself have to take that output and change the program and do whatever else, they're not going to use it. So instead, work with people. Don't create friction and don't start over. And then the last part to this, and so how you can do that, sorry, the solutions. One easy thing that I can think of, just put it right into the software engineer's IDE, right? We talked about linters. That's just a VS Code admin. Oh, and on that point, VS Code add-ins are definitely a way for supply chain attacks to occur. I personally would emphasize that, yes, that is true, but this is also the easiest inject to get your software engineers to do secure code quickly, because they're already doing some sort of that with just like the built-in native kind of automation that comes from writing code. So putting it in is kind of an easy no-brainer. Or the other part of the kind of code submission process, put it into that CI/CD pipeline. Also secure that CI/CD pipeline. But definitely, that's a great place to put it there as well. Just right before they hit the kind of submit code button, or letting everyone know that, hey, maybe this commit is too long, or it has a code smell, or even worse, isn't this that CVE vulnerability that came out a couple weeks ago? Don't code that. Yeah. As the world of IR goes, it depends. So yes, there absolutely is a way, but it is a little more convoluted than just saying, I'm going to dictate these things to you and kind of rule with that iron fist mentality, which is why, again, security, I think, is everyone's job, and they should be aware. So as for the last point, training that doesn't suck. She Hacks Purple had a really good talk where she said this, and it stuck with me for quite a while now. Truly, we train our users all the time to not click on phishing emails. Well, how about you train our users to write secure code, or identify secure code, or more importantly, identify insecure code, or coding practices. I think it's super important. And I think that is where you have to then go to the security analysts and say, what are we doing about this? But you also have to go to the software engineers and say, what are you doing about this? Do you even know it exists? Hey, real quick, do you know what a code smell is? Like, ask these questions to everyone, because I think everyone should be in the know. And so with that as kind of a last-ditch effort, some of the things I didn't really touch on include hardening your development environments like it was prod. Please, 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 just because you call it the development environment doesn't mean it's not running in your production environment. Another thing, memory safe languages, excellent mitigation for a lot of vulnerabilities, and it just makes it very easy for your software engineers to not have to go back and rewrite or refactor their code because you just got popped, or the lovely bug binding program you hopefully pay for or are a part of, they came back and said, hey, we have like 12 users that found the exact same thing. You should fix this. And then other last ditch things, communication is key. And that's actually really my main last point. Whether it's written in a playbook, whether it's written in a chat message, do yourself a favor, use the no hello mantra, and keep in mind that the other side wants this to succeed too. So with that, thank you so much for coming to my talk today. I really appreciate it. And thank you for being a kind human. Thanks.